A function is differentiable at x equals a if it's continuous and smooth at x equals a, meaning that it evaluates at the same derivative as x approaches a from the left and the right. So this function here is continuous because it can be drawn without lifting the pen. And as x approaches a from both sides, so we can draw the secant from both sides. So you can see that this limit is going to be the same from both sides, and the slope of both secants are going to approach a slope at the tangent to the curve at x equals a. Now for this function here, it's continuous, but it's not smooth. As x approaches a from the left, and as x approaches a from the right, you're going to have two different slopes. So as you can imagine, as x approaches a, then the slope is basically going to be vertical. So in this case, the slope is infinite, regardless of whether the function is continuous. So the derivative does not exist in this case. So for these other two examples, from the right, we can see that this limit is going to approach a finite value. And from the left, if we draw a secant line from some value x to a, well, we can see that as x approaches a, we're going to get a vertical line as x approaches a from the left. So therefore the derivative does not exist because as x approaches a from both sides, this limit is not the same. And similarly here, the function is discontinuous, so the derivative does not exist. And that can be clearly seen by observing what happens to the slope as x approaches a from both sides of a. Is this function differentiable? So first we check for continuity. So f of minus 1 exists. And the limit as x approaches minus 1 from the left and the right is the same. So because these are equal, the function is continuous. And now we need to check if the function is smooth. So we take the limit as x approaches minus 1 from both sides of f of x minus f of minus 1 over x minus negative 1. So as x approaches minus 1 from the left, then we take this as f of x. And f of minus 1 is 3. And as x approaches minus 1 from the right, we take this as f of x. Which simplifies as follows. So you can clearly see that these are two different limits. And without doing a factorization and evaluating them, we can see the function is not smooth. And therefore the function is not differentiable at x equals minus 1.